Hey, welcome back to Zig for the Uninitiated. It's your host, Tyler. Today we're going to talk about the Zig Allocator interface and interfaces in general. And this is going to be a pretty technical topic, probably more technical than any of the other ones that we've done so far. So I hope I'm able to explain it pretty well. If not, please make sure to leave some comments, and let me know if you have questions, and maybe we can go over some things in the next video. So let's talk about the allocator interface. So if looking back at some code that we've talked about, that we've looked into in the last few videos, I want to highlight a few things. On line 10 here, we have where we create our general purpose allocator. And I call it the GPA. But then the line below, you see I create the allocator by calling the allocator function on GPA. And I remember when I first learned Zig, I was really confused about what was going on here. And there's actually a really simple explanation for what's going on here. But because Zig doesn't support interfaces, and I'm giving it away right now, it's because Zig doesn't support interfaces directly. It can be sometimes hard to understand what's going on there unless you dig into the code and you kind of get to understand what the purpose of all this is. And the purpose is that if we jump down 17 lines and get message, we want to be able to allow our users who use our functions to pick and choose what kind of allocator they want. In fact, that's one of the big benefits of having a language that forces you to choose your allocator, is that you're able to choose different allocators, right? You're not stuck with malloc or with whatever, allocator that the Python interpreter chooses to use, or anything like that. You can pick. But because we want them to pick, we need to be able to have some kind of interface to the allocator that we can then pass around that's more generic than just a implementation, right? If we change this to be a heap dot general purpose allocator, we could do that, but now everyone who wants to use the get message function would be forced to use the general purpose allocator, and maybe that's not what they need or what they want, or maybe not even possible. Right? Maybe the general purpose allocator requires some things that they're running on hardware that they're not able to use. So we're going to use the standard mem allocator. And like I said, and I've alluded to, this is an interface. And in other languages, you can create interfaces quite simply. You use some kind of interface syntax. Perhaps it's the interface word itself, or protocol, or trait. You'd use some keyword like that, some syntax like that, and you'd get a nicely defined interface. But the question is, what's actually happening there? So Zig doesn't let you do that. Zig doesn't let you create an interface via syntax. What you have to do is do it by hand. And so what you have to do is understand how interfaces work under the hood. And so that's what I wanted to kind of explain today. I thought it'd be a fun thing to understand and help you understand how the allocator interface works in Zig, as well as how other interfaces work. So if we come over here to Excalidraw, we can see I've written some Java code here. And this is how you do it in Java. If we were going to make an allocator interface in Java, you'd use the interface keyword, call it allocator, and you define the three functions that you need. You need an alloc function, we need a resize function, and we need a free function. So here we have alloc, resize, and free. And then you create some concrete class that implements the allocator. And in that implementation, you implement an alloc, a resize, and a free function. And in fact, it would be a compilation error if you didn't implement any or all of those three functions, because the interface that we're saying that we implement requires that we have that. And then once you'd implemented that interface, you could create a new allocator or new GP allocator, but assign it to a variable that has the type of allocator. And in this way, we're kind of getting a generic version of allocator, right? And that way we could, at runtime, switch out the allocator or create an array of allocators and change between them. Or even just make it really easy to change it statically, right? Instead of using the GP allocator, I want to use this other allocator. And we don't have to go and change the code everywhere else. It all uses the same, generic version or generic interface to an allocator. So what's happening underneath the hood? Well, underneath the hood, what we are doing when we implement this interface is we're actually telling the compiler that it needs to add a hidden field to our class. It's going to add this hidden pointer to a vtable or a virtual table, or sometimes called a virtual method table. We're going to call it a vtable. And the vtable is defined by this allocator interface. It's going to say, hey, you need a pointer to a function that contains a byte, not a byte, an alloc function. You need a pointer to a resize function. And you need a pointer to a free function. And that's all defined in this vtable, and then is put, a pointer to this vtable is put on the class. And then when we instantiate this allocator and we, cast it in a way to an allocator type, what we're really saying is, hey, I have a vtable that contains the methods that this requires, and it's going to just access those methods. And you get a bit of what you can consider some type erasure, because once you pass this myAllocator, we don't know what the original type was, per se. And so we can only access these functions that are defined in the vtable. That's what's happening under the hood. Well, in Zig, there is no hood, right? There's no syntax sugar for creating interfaces. So we have to do it by hand. So what do? If we look at std.mem.allocator, you'll see that it is a struct. It contains a field called pointer. And that is a pointer to an any opaque. We're not going to get into any opaque right now. Just know it's a pointer to the original structure that we created the interface from. Kind of like it's a pointer to the child in a way. We don't need to worry about that. What it also contains is a vtable, which is a pointer to an object of type vtable. And well, what type is vtable? It's defined in the same file, vtable. It's a table that looks exactly like what we described here. It has a pointer to an alloc function. It has a pointer to a resize function. It has a pointer to a free function. So then, on the general purpose allocator, it defines a function with alloc, a function with resize, and a function with free. But how do we get this benefit, right? Where we can then cast our allocator, our specific type of allocator, to this kind of generic interface of an allocator. Well, we can't do it directly. What we have to do, and what we see in the general purpose allocator, is create this vtable or create an object of type allocator. So what we are doing is we're saying we can do like our GPA and call the allocator function on it. And that returns our allocator that contains this vtable. So if we go back to our code, I think it makes a lot more sense now. We have the general purpose allocator which is our specific kind of allocator. But then to pass around to functions that take a generic allocator, we call the allocator function, which if we look at it right here, just returns a pointer to itself and a vtable, which is a pointer to this statically created table here. Alloc, resize, and free. So that's what's going on when you see this kind of incantation, which seems a little strange. But once you get into it, you see that the standard library actually uses this quite a bit. And in fact, we use it again here on line 17 with the writer function. Writers in Zig are often just passed around as an interface that uses a specific write function. So as long as some struct implements a write function, it can also implement the writer function, which returns a generic object that references its write function. So that's how you can then take, for example, the array list and turn it into a writer and write into this dynamic buffer. Well, that's all for today. I know it was probably a little technical. Hopefully it was easy to follow. Next time I really want to get into some of the specific allocators, like the page allocator or the general purpose allocator or the arena allocator, and look into their implementations and understand what's going on behind the scenes. Once again, let me know if you have any questions, comment below, or go to the Discord. Happy coding.